Hi, everyone. My name is Tamar Heyman, and I'm a Principal Product Manager on AWS AppFabric. You should listen to this session if you are experiencing SaaS sprawl in your organization, if you care about improving the observability over SaaS applications deployed in your company at reduced effort and lower cost, and if you would like to strengthen your overall security posture from your infrastructure layer to your SaaS layer. In this session, we will unpack some of the challenges associated with achieving observability over your portfolio of SaaS applications. We will show why AppFabric's approach simplifies complexity that security teams face when they manage a multitude of point-to-point integrations of SaaS applications. And we will demonstrate how, with AppFabric, security teams can free up their much-needed capacity to focus on strategic and value-add tasks. Okay. There you go. Sorry. As mentioned earlier in the keynote, large organizations are deploying an average of 125 SaaS applications. To achieve observability over the data that may be lost or exposed in these applications by employees and contractors who use these apps, there's quite a lot of tasks involved. Integrating observability tools with the SaaS applications that are used in a company can take weeks or even months per application. The tasks involved include things such as researching API documentation of each app, doing the actual integration work between each application, normalizing the data into a schema that is compatible with their security tool, and parsing the data to enable better threat detection across multiple systems and resources. And normalization is the task that takes the majority of the work and effort. And this is just setup cost and setup effort. On top of the initial setup, customers also need to maintain these integrations on an ongoing basis, and this can add up another week or more per application every year. And while many security tools do offer integrations with SaaS applications on their marketplace, these applications still require a customer to normalize the data into a compatible schema, to maintain the integrations. And in fact, a lot of these integrations are actually developed and offered by the developer community and not fully supported by the security vendor. So the security vendors themselves are faced with a challenge here where their customers are asking them to support more and more SaaS applications that they're adopting as fully supported out-of-the-box add-ons. And this takes away from a security vendor's capacity to invest in their threat detection capabilities and in a delightful user experience. And that's exactly where we would love for them to continue spending their time and effort. So all of these factors result in security teams being bogged down by data pipeline management rather than being able to focus on monitoring and threat detection. We have validated and heard these pain points time and time again over months of conversations with our customers. And I'd like to share some key themes that we've heard with you. So customers tell us that detecting anomalous behavior is critical, especially as it relates to SaaS applications, but it involves a lot of manual effort. They told us that their security teams are spread thin and that they often have to trade off data pipeline management with threat detection and event response tasks. They told us that normalization specifically is the task that takes the most effort and pain for them, normalizing that data so it's compatible with their security tool. So teams often have to prioritize which apps they're integrating into their security tool, which apps they're maintaining integrations for, which means that some apps go unmonitored, and that leaves customers exposed. So why is normalization and standardization so hard? And why is it so resource intensive? Well, there's a few key reasons for that. First, the data frameworks are quite different when you move across SaaS application categories. For example, Slack organizes its data around messages and channels. Dropbox does this with folders and documents, and Asana with tasks, projects, and goals. So when you look at trying to make sense of similar user behavior across application categories with different data objects and frameworks, it becomes quite complex. The second reason that it's difficult is because while normalization is required for a customer to be able to standardize their rules and alerts and notification on anomalous behavior, it's often not sufficient. And customers actually have to undertake data enrichment tasks as well. For example, each application assigns a specific alphanumeric identifier to a user. and they're different across applications. So it makes it hard for a security analyst to know whether the same user on app 1 that's doing certain behavior is the same user they're looking at at B. And third, the data ingestion and data integration approaches will be different across applications. So the data freshness of audit logs that are generated by each application will be different. And also the API rate limits will vary across applications. And so customers who want to integrate with these applications and start consuming audit logs, they need to undertake these customized integration approaches by application. Let's take a real-life scenario. An example. Here we have two users, user 1 and user A. They're taking actions in two applications. In this example, it's Dropbox and Slack. The actions they're taking are suspicious because they could indicate that company data is at the risk of being exposed, and this company data could have personal identifiable information about those companies' customers, or it could have commercially sensitive information that the company wants to keep close and secret. And so if we take this example, let's walk through a scenario. In this example, user 1 is an administrator of the Dropbox app. And the first thing they do is to remove all other administrators of that application, leaving themselves the sole administrator of Dropbox. They then proceed to download an irregular amount of files within a 30-minute time frame in Dropbox. Around the same time, user 1, who's also an administrator of the Slack app, changes the list of users who are authorized or have permission to share content externally on Slack channels. They add user A as one of those users who has the permission to share content externally. And in fact, and indeed, immediately after user A begins to do that, they create a link that allows them to share a file externally outside of the company on Slack. So these events are happening across multiple applications. They're being represented quite differently by each application's data framework, as you can see with some of the examples on the screen. They're suspicious, and there's no real way of knowing just by looking at it if user 1 and user A are the same human. So what does this mean? It means that a security analyst who's looking at all these events and user behavior needs to have app-specific understanding and context of the framework and objects for each application. They need to make sense and normalize all these events so that they can standardize their alerts and notifications. And they need to have a mechanism to know if these two users are the same human or not, because the enforcement actions will vary accordingly. So thinking about that example, how does AppFabric actually help address some of these challenges that a security analyst will face? Well, first we address the normalization challenge. AppFabric, as you've heard today, has adopted the Open Cybersecurity Schema Framework, or OCSF, as the framework under which we're normalizing audit logs from SaaS applications. And a few notes on this. So OCSF is an open source schema and initiative that is led by AWS and leaders in the cybersecurity industry. The AppFabric OCSF schema was actually developed by working back from the MITRE ATT&CK framework, which is an industry-accepted framework for documenting common attack threat vectors and attack techniques, and based on real-life observations. And we did this because we wanted security analysts to be able to extract immediately relevant information for the purpose of threat detection. And lastly, the AppFabric schema was developed to better represent SaaS application audit logs rather than infrastructure audit logs, because the two are quite different. Monitoring infrastructure audit logs will look more at the performance and reliability of a service, whereas monitoring SaaS applications audit logs will look more at anomalous user behavior. And so that is what we've done around normalization. The second thing we've done, as you've heard today, is enrich these audit logs with a unique user identifier, and we rely on information such as corporate email address. So these two things combined, the normalization and the enrichment, means that security teams can extract more value more efficiently out of their audit logs. So Fabric extends the OCSF schema to be a SaaS-centric framework for monitoring application audit logs. AppFabric has basically evolved 5 OCSF event classes, and they're listed on this screen, where we provide additional details and more activity names that are more appropriate for SaaS applications. And so if we think about that hypothetical scenario we just discussed where user 1 and user A are taking certain actions in Slack and Dropbox, then those events would be normalized under the user access management event class, the web resources activity class, and the web resource access activity class. And we've highlighted in bold and blue font the activity names that would be relevant for all of those behaviors we just discussed in that scenario. So for example, when user 1 changes or removes all the administrators on the Dropbox app and leaves themselves as the sole administrator, that would be normalized under the revoke privileges activity name. Or when they proceed to download an irregular amount of files on Dropbox, that would be normalized under the export activity name, and so on. And one last thing to note on this is that the unique user identity that is offered through the AppFabric normalized logs is included in the raw data field that is part of that schema. So customers are currently managing a web of integrations between their applications and the security tools that they would like to use. And they have to undertake normalization, enrichment, maintenance tasks. But with AppFabric, there's no need for any of that because customers can basically use AppFabric to manage their integrations, to normalize their data, to enrich it. And they can use all this data and make sense of it in their preferred tool, which includes supported solutions such as Splunk, Rapid7, RSA NetWitness, and more. So how easy is it to get set up and started with AppFabric? We have a demo that we'd like to show you on the very simple steps that it takes to set up AppFabric. In just a minute. Here we are at the, for the purpose of the demo, we're using the Zoom app. And for Zoom, a customer first has to go to the admin console and in Zoom and create a server-to-server OAuth app. That's the way that Zoom creates an integration between their audit log APIs and a service like Fabric. In the admin console, a customer will need to take these credentials and put them, use them as inputs in the AWS Fabric console. So we are now going through setting up of that OAuth server-to-server OAuth application in Zoom. It's just a few easy steps where after we copy those credentials from that first step, we complete providing the contact information, which is a required field, proceed through additional steps like defining scopes. Scopes are kind of the scopes that AppFabric will be authorized on a company's behalf to pull audit logs for them. So things like the different user activities that are occurring on the Zoom app, the admin activities that are occurring there, all of these things are the scope we are adding here to be able to provide customers with full visibility on the events that are happening in Zoom. All of this is, by the way, documented in our documentation on the AppFabric homepage. And so we've created this app, and note that it's not public or published anywhere. It's just for your internal purposes for authorizing AppFabric. Here we are on the AppFabric console, and there are just 3 steps that you need to take here. It's very simple. The first step is to create an app bundle. An app bundle is a concept of like a container that stores all of the information related to your AppFabric resources. And that is where you will also provide your preferred encryption method. So this is how we will encrypt the SaaS app data that we will be ingesting on your behalf at rest and in transit. And so that is the first step. You have 2 methods you can choose here. The first is to have an AWS-owned key or a custom key, a customer-managed key. Both are the same, meet the same high security bar that AWS is known for. The second step is here to create an app authorization. And as you saw in that drop-down, we have 12 apps supported right now. So we're proceeding to provide the app authorization credentials that we just saw at the beginning here in this page. They were all available in that first step of the Zoom OAuth app setup. And so we're providing a tenant ID. A tenant is the app workspace or an app instance. And so it's for that app instance or workspace that we're providing credentials in order to let AppFabric start pulling audit logs on our behalf. And the last thing we're doing, the last simple step, is to provide some configurations around the destination for the data and the format. As you can see, you have a few choices to make here, so it gives you a lot of flexibility. The first is the destination as an Amazon S3 bucket, either an existing one or creating a new one, or an Amazon Kinesis Firehose. You also have a choice, if you saw that earlier, where you can select the format for those audit logs. Those can be normalized into OCSF or raw. They could be in JSON or Parquet, and Parquet is especially helpful if you want to use this data in Amazon Security Lake for a kind of more in-depth analytics use cases. And that essentially was it. It was 3 easy steps. No developer effort needed, no integration work that you need to do, very simple UI to work through to set up an ingestion. And you're already having the ingestion set up. As you can see here, it's connected to Zoom. Audit logs are being ingested in the configurations that you've selected. We're just showing you here now what it would look like after you've gone through this setup and you wanted to kind of look and check how that ingestion was set up. So here are all the settings that you provided, including the app authorization credentials. That's what it would look like once set up. And it's active, which is exactly what we like to see. The destination is Amazon S3. It's normalized into OCSF, and it's in JSON format. All the choices that in this demo we made. And by clicking on that link, you will land on the destination that you chose, which was the Amazon S3 bucket, where we already have audit logs being delivered. So this is how simple it is. As I said, a few simple steps. You are guided through all of it. There's documentation and guides to help you navigate for each application. Where do you pull the inputs required to set this up? And that is it. So I hope you're convinced that it is very simple. And you have to repeat this for every application, but you only have to do it once, and you don't have to go back and maintain or do any of that. So thank you for listening to the session today. Please stay with us, because right after this session, we will actually show you what you can do with this normalized data that you get from AppFabric with tools such as Splunk to improve your overall security posture. And I have time for a question or two before we go to the next session. Thank you.
Great, thank you, Tamar.
Sure.
Yeah, if there's anyone who has any questions, feel free to step up to the mics. A couple questions that I got for you.
Yeah.
Someone asked, why did you choose OCSF? You mentioned that a little bit earlier. Maybe you could elaborate why that was chosen as the normalization. It's kind of a new schema. What was the kind of reasoning behind that?
Yeah, it's a great question. There's 2 key reasons why we chose OCSF. The first one is because, like also we explained in this session, it was designed and developed to address the needs of the cybersecurity professionals or the security industry. So the schema is organized around the types of events and app categories and behaviors that are most pertinent for security analysts to review and monitor. And the second reason is because using OCSF allows a customer to centralize the observability over not just their SaaS applications, but also their AWS infrastructure resources using the same schema, the same framework. So those are kind of the reasons we chose that.
Okay. Another question that came in. Recently announced in general availability was Amazon Security Lake.
Oh, yeah.
Amazon Security Lake is a centralized location for all your security data across AWS environments, SaaS providers, on-prem environments. Can you give us any insight about AppFabric and Amazon Security Lake kind of work together?
Yeah, they actually work together very well, and we are very happy to say that our data is actually available, and customers can use it in Security Lake to address needs of like very deep, rich analytics for security use cases. So one way to think about it is that Amazon Security Lake is a destination for AppFabric normalized data, and where customers can centralize kind of all of their resources to achieve that observability and run analytics use cases. And the second thing to say is that another way to think about AppFabric and Amazon Security Lake working together is that AppFabric is the kind of single source of SaaS application data for customers that use Amazon Security Lake. So by using AppFabric, customers can get aggregated and already normalized into that data already normalized into a schema that is compatible with Amazon Security Lake. So the two are quite complementary and work very well together.
Awesome. Yeah, that sounds perfect. They sound like they're made for each other.